Hello folks, this is 2024 October and November paper 4-3 and the question belongs to chapter electric field. It is question number 5. The first question says state the relationship between electric field and electric potential. So it is simply if in equation is in the form of E equal to minus dV by dr, and in words it should be the electric field is equal to the negative of the potential gradient, electric potential gradient, that is change of a potential with respect to distance. So next is two charged isolated insulating spheres x and y are near each other, x and y near each other, as shown in figure 5.1. So we can see figure 5.1 here. P is a point on the line joining the centers of the spheres. So centers of the spheres here, this is the line and P is here. Explain why it is not possible for the total electric potential and the resultant electric field to simultaneously be zero. So we have to explain why it is not possible that the potential and the field are simultaneously not zero. So let's say that the potential is zero. Let's say that the resultant potential Vp here is equal to zero. So in that case, what we have is, if I say Vp is equal to 0, then I must have Vx plus Vy at that point is equal to 0. And that will give us some charge here, Qx by something something plus Qy by something something equal to 0. And that gives me Qx by this something something equal to minus Qy by this something something. So that means if I have the potential 0 here, the charges should be opposite. The charges should be opposite, as shown by this. Now, let's say they are opposite. So x is positive charged and y is negative charged. So if so, then at this point P, what we have is the electric field will be in this direction, electric field in this direction, due to this is in this direction, and due to this also is in this direction. So E can't be 0, because both of them say that the electric field will be in this direction. So it will be added plus, so it can't be 0. So when potential is 0, the electric field cannot be 0. One thing. Next is, if I say the E is 0, if I say here E equal to 0, E resultant equal to 0, it means that the field line here should be like this and like this. The field line here should be like this and like this. So they should cancel each other. It should have some value. E0. Now if I take the potential here, potential has no direction, so this and this will add. So add means it will have some value. So when E equal to 0, V has some value. So that means, so what we have is, if one becomes 0, the other becomes non-zero. If one becomes 0, the other becomes non-zero. So that's why it is not possible for both of these things to be 0 at the same point, as explained here. Then number C. The magnitudes of the charges on spheres x and y are q and 2q. So here it is q and here it is 2q. Respectively, the spheres may be considered as point charges at the centers. Okay, we always do that. Point P is the distance x from the center of sphere x. So this is small x here. Next is electric potential at P is 0. So we have a Vp total is equal to 0. So that the distance y of point P from the center of sphere y is equal to 2x. So this is distance y, and we have to prove that this is equal to 2x. So what we must have here is, so if Vp is equal to 0, I must have the potential this and this and this. So I say Vx plus Vy should be equal to 0. That means Vx is equal to V minus Vy. So Vx is equal to Qx divided 4 pi epsilon x equal to minus Qy divided 4 pi epsilon naught into this y equal to, this thing is equal to 2q. This is q, this is 2q. So we should have q by, so this and this cancel, q by x is equal to 2q by, qy is equal to 2q by y. So q gone, so therefore y is equal to 2x. So which is what we have to prove here. Okay, so after that, the next question is, now state an expression in terms of Q, X and permittivity of free space for the electric field strength Ex at P due to sphere X. So we have to first have the expression for the E. So E is equal to simply Ex is equal to Qx divided, it is E here, so it is 4 pi epsilon naught x squared. That's the expression for Ex. Now, determine an expression in terms of Qx and this thing for the resulting electric field strength E at point P due to spheres. So what we have is E due to X is this much. So E due to Y is, E due to Y should be equal to, it should be 2Q here, 2Q, then 4 pi epsilon naught, then it is 2x squared. We got to 2x in the previous calculation. So it's equal to 2 to 4. So Q by 2 pi epsilon naught into 4x squared. This becomes Q by 8 pi epsilon naught, then x squared. So this is the field due to this y. Now, it is said that the potential here is equal to 0. Potential zero means that the charges should be opposite. Now, if we have opposite charges, what happens is, if this is plus and if this is minus, the field here will be like this because of this, and the field will be again like this because of this. So they add. The resultant field here will add. So that's why we have E resultant is equal to simply Ex plus Ey. That's equal to Qx by 4 pi epsilon naught x squared plus, this is Q only. Here. Now it is Q by 8 pi epsilon naught x squared. So the common is 8 pi epsilon naught x squared. So 4 2s are 8. It is 2Q plus Q equal to 3Q by 8 pi epsilon naught x squared. So this is the value of total E here. So this is the answer to this question.